A theorem in geometry is a statement that we've proved or somebody else has proved. So it's not just because we've actually shown why this is true. Our first theorem we're going to look at, and once again, do not go by the numbers, just cross out those numbers, is midpoint theorem. If a theorem has a name, we're probably going to use it quite often. If it has a highfalutin name, sounds kind of complex, it's probably even more important. Here's what our midpoint theorem. It says if M is the midpoint of AB, then AM is congruent to MB. Because M is exactly in the middle. That's where that comes from. Now we're going to do another type of proof right now. It's called the flow proof. Flow proof means flow chart. That's where it comes from. So you're going to describe your thinking in your flow proof. Some people, once I show them how to do a flow proof, they like to do flow proofs all the time. Other people prefer the two columns. When you follow an assignment, you do what it says. If it says to write a two-column proof, you write a two-column proof. If it says to write a flow proof, you write a flow proof. If I don't tell you either one, you can decide. But make sure you follow directions. I'm going to show you another reason in this chart that we haven't come across here. We're given that segment FG is congruent to segment HK. We want to write a flow proof to show that X equals 7. So just like any proof, we start with the given. Now we have 3 givens here. 2 of them are in the picture. One of them actually says given on it. So our first given, we're going to say FG, segment FG is congruent to segment HK. And when you do a flow proof, you put your statement in a box, and just beneath the box, you write down the reason. So our reason here is going to be given. Now, your mind will go to the next one. Now, not yet, because I'm going to show you, but anytime you have a congruent statement, you can change that to an equal sign. Notice, we're given a congruent, but we want to prove equals. So we have to change this congruent sign to an equal sign. So anytime you see a congruent sign, you could automatically change it to an equal sign. Shapes are congruent. Numbers are equal, or distances are equal. So if I'm told FG is congruent to HK, what follows from that is FG equals HK. So you get rid of the congruent sign and the segment, because now we're talking about the distance. This is called definition of congruent. In this case, congruent segments. There's congruent angles also. And that's what we know from the given. Now let's look at another given. We're also told FG equals 4x minus 6. So I'm going to write given there. We're also told HK equals 22. I'm given that. Now what we're going to do is we're going to put all 3 of these together. When you put them together, that's substitution, because what we're going to do is we're going to take FG, instead of writing FG, we're going to write 4x minus 6. Instead of writing HK, we're going to write 22. So that's what I'm going to say next. I'm going to say, 4x minus 6 equals 22. That follows, from all 3 of these. So I'm going to put an arrow to all 3 of these. What's that reason? Well, that reason is substitution. Now, we're just going to, from that, we're going to flow. So since our flow proof, we're going to do the algebra. We're going to add 6 to both sides. So I'm going to draw my arrow. If I add 6 to both sides, I get 4x equals 28. And that's because we added the same thing to both sides. And then from there, we're going to have x equals 7. Why? Because we're going to divide the same thing by both sides. That's division property of equality. I'm going to shrink this and we can see the whole thing. So spatially, it doesn't matter how you do this. Notice sometimes I go across, sometimes I go down. I went down this time with my arrows. As long as you show me what your thought process is, that's what it is. So this is really an algebraic proof, except we had that very beginning part that was geometry. But that's about it. Now the third type of proof we're going to look at is, well, we'll do that in the next part of the seminar.